Naked Yak coming to you live from room A301. Shout out to my good friend Beryl. So, if you have this, you can do it, yeah? Because 12 and 65, we already did this on the board. If you...
We copied it from...
You copied it off there? Yeah. You guys are so smart. Did I tell you to do that?
You said...
Crap, yeah. That's... Oh, okay.
You said only if we wanted to.
All right. So you did question number 1 too?
Yeah.
Oh, stop it. You're the best. So it should have looked like this. Right? It should have looked something like this. Who chooses where A is? You can, right? So if this is 40, right? Now, the way, depending on how you drew it, obviously this is the bigger angle, yeah? But it also looks bigger than 90, right? The way I've drawn it. So this could be 75, yeah? Everybody cool? Doesn't really matter, does it? What does matter is how you label it. If I make this A and this 75, then what does this have to be? B, and AB would have to be 6. Agreed? Now, here's a problem with that, and here's what's going to happen if you put B down here. What does that tell you? How big is this angle? How do you know? Why is it 65? 180, right? So that makes that have to be 65. Everyone agree?
Yeah.
Okay. Now, that makes that C. Yeah?
Yeah.
Which makes this little c, correct? Which make this little b, which makes this little a, yeah? So then we get, according to the sine law, and by the way, these are reversible. You can put the sines on top and the sides on the bottom. It doesn't matter. Some textbooks write it sine on top, some write a on top. It doesn't matter. It's the same thing. So according to the sine law, 6 over sine 65 must equal A over sine 40. Agreed? And it must also equal B, which looks like a 6, over sine 75. Does everyone agree? Okay, now, to do this, I trust that everybody remembered how to cross multiply, but a couple of people had to come up and ask me afterwards, so I'm going to remind you of something. Every time, everywhere in math, you have fraction equals fraction. Anytime you have that, and you have one unknown, you always cross multiply the pair and divide the spare. Okay? So here I have two fractions, don't I? Because sine 65 is just a number, isn't it? Right? So I have a pair, 6, and I'll do this with a different color than I've drawn. 6 times sine 40 divided by what's left over, sine 65. Everybody cool? So to punch that in your calculator, 6 sine 40 in brackets divided by sine 65. Depending on how your calculator works, of course, right? If you've got a backwards calculator, you got to reverse all that. The key is you got to remember these brackets for most calculators, so you might as well do it for all. So if you drew it this way, how many people drew it this way with 40 and 75 on the bottom? Okay, there's a reason. 6 sine 40 divided by sine 65. That would make A 4.3, which would make this side 4.3. Is everyone okay with that? We're still not sure if that's okay, because we got to find the other side first, which means I then do the same thing. This side is 6 sine 75 divided by sine 65. So 6 sine 75 divided by sine 65 makes this side 6.4. Now check, is that okay? Is this the biggest number? Is it across from the biggest side? Yep. Is this the smallest number? Is it across from the smallest side? Is this the middle number? Is it across from the middle side? So is this triangle okay? Now, what if you put your 75 up here, which would then put your 65 down here? Would that change anything? It doesn't, does it? You still got 75. It still works. You still get the same distances on the sides. Everybody cool with that? Because this is just a representation of a triangle. Okay? It is not the triangle. And it's very important that you guys get that no matter where you put it, it still works. I'm going to show you something today that is a little weird that deals with this seemingly strange phenomenon, right? Like this shouldn't work. If you put your 65 and 75 there, you would think you would get different numbers, wouldn't you? But you didn't, did you? Or did you? Is everyone okay? All right. So number two, I switched letters to D, E, F. Now I noticed a couple of you aren't 100% sure on solve the triangle. What does that mean? Find all sides and all angles. We did that in the first part of the unit, but some people seem to have forgotten that. So, does it matter how you draw this? You start with an angle, 35 degrees. That means that's D, yes? Okay. And we know that across from D is 7, because little d is 7. Everyone agree? Do the other two matter? No. Right? If I make this E, then that makes this big E, correct? And that makes this big F and little f. Everyone cool? I could also draw it this way, though. 35, D, 7, F, little f, E, little e. And it's not going to matter. Why? Because the fractions are still going to cross at the same spots. Everyone cool? So, does everybody understand how to draw it? Because that's notes, right? You guys haven't seen that yet. Because I didn't tell you to do number 2, did I?
No,
okay.
you said not.
Okay. Is everybody cool with why both of those are all right?
Yep.
I am holding up, Elma.
You forgot to put in the 12 centimeters. Yes.
Oh, yeah. E is 12. Sorry. E is 12 and E is 12. Is everybody cool? Yes. This is not news to anyone here, yeah? All right. So now I want to find out what? I need big F, little f, don't I? If I know big E, do I automatically know big F? Yeah. So I'm going to find big E, right? I know I can use the sine law because I have a pair. Everyone agree? Yep. There's my pair. So I know I have 7 over sine 35. There's my pair. Now everything works from there, okay? In black, I have 12 over sine big E, don't I? Everyone agree? Okay. So let's solve that first. Multiply the pair, divide the spare, right? So that's going to be 12 sine 35 divided by 7. Yeah? Now here's a trick that's going to mess you up. When you punch that into your calculator, what are you going to get? What do you get? Punch this only into your calculator. What do you get? 0.98, right? Is that an angle measurement? Or is that a sine measurement? Sine measurement. What's the last thing you got to do to get the angle? Shift sine. I got to remember to shift sine that. So I get 80 degrees. Is everyone cool with that? Is everyone good? Everyone is okay? So E becomes 80. Now, watch what happens over here in red. Does anything change? 7 over sine 35 still gets me 12 over sine E. Do you see how it doesn't matter how I draw it? Because this is just going to put my E down here, and that's going to be my 80. Is everyone okay? Once you know 80 and 35, that's 115, right? So what's our last angle? 65 and 65. Now I have a pair, and I can work with sine F and 65, or sine 65 and F. Everyone cool? So my last step is going to be 7 over sine 35. Do I have to use 7 and sine 35, or can I use 12 and 80? I could use 12 and 80. Why is 7 over 35 the better choice?
Because you used it before.
Well, because I rounded this, right?
Yeah.
It was actually 79.5 degrees, yeah?
Mm-hmm.
So I'm going to use the one that was given to me solid. Everybody with me?
Yep.
Now the other one will work. You'll be within like 0.1 of a degree. That's fine, right? Because you're going to always show me work, and I'm going to know you know what you're doing, correct? So what goes here? I need F. So it's little f over sine 65. Multiply the pair. 7 sine 65 divided by sine 35. And that will get me F. F is a value, so there's no shift signing because it's the side. Cool? And you punch that into your calculator however you punch stuff into your calculator. And what do you get?
11.
11. So F is 11. And that would have worked on both. Is everybody good with sine law? What's the only thing you need to do sine law? Any pair. Okay? Once you have an angle on its opposite side, you can do sine law. Everybody good? Yeah? Okay. Moving along. Does anybody know what the word ambiguous means? It's used all the time. Ambiguity and ambiguous. But a lot of people don't really know what it means. That's okay. Not so much different is not definite. Okay? If you are being ambiguous, here's a good one. Unclear. Yeah, that's better. Okay? Here's a good one. How are you feeling? Fine. Am I feeling fine? No. Right? How's it going? Good. Is it going good? No. Status update on Facebook. Blah, 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 ... What the hell does that mean? 85 comments. What's the matter? Why did the person do that status update? So 85 people would go, what's the matter? If I were to do a status update, I would say, I'm sad because blah. But of course I don't. Everybody okay with ambiguity? All right. So let's show you what I mean. Everybody over on the left here, so I have room to do the definition on the right. On the left, sketch this triangle. Be careful. What? You guys don't have ambiguous triangles?
Oh wait, no, it's the same thing.
It's the same
just a
one.
different number.
It's just it's like the layout's.
Let me see yours.
It's the same thing, but that's number
36, 3.
Number 4 is actually number 3.
That's a 3.
Oh, is it?
46, 3. Everyone's cool? Okay. Okay.
It just doesn't say number 3. It says 2, 4.
Okay, cool. That's okay. That's okay. That's okay.
5.
That's okay. That's okay. But you guys have A30, AB6, and BC
3.
3 is your first one.
Yes.
Okay. All right, so let's draw that. I need an angle of how much?
30.
30. Does it matter what I actually draw it as? No. 30 degrees. Everybody cool? Okay. And if that's 30 and AB is 6 and BC is 3, I'm going to go ahead and make this guy 6 because I'm in charge of this triangle, yeah? Everybody cool? Which makes this A, this B, everybody good? Which makes this have to be C, correct? So we would draw this third line in. Now draw that dotted. What math might you be able to do with this situation? Sine, right?
Yeah.
Because I have a hypotenuse and an opposite. Everybody cool? All right, now, what would it look like? It would be sine 30 would equal opposite O over 6. Everyone agree with that?
Yep.
Okay, so this would be 6 sine 30 would equal my opposite, correct? Everyone good? So you do that on your calculator, and what do you find O to be? You find it to be 3. Is everyone cool with that? Now, look on your notes. This is side BC, correct?
Yeah.
And BC we've already been told is 3, yes? So, this side here is also, I'm going to call it the H. Not hypotenuse, H for height. H equals a word we call altitude. We use this in the first unit. Every time you draw a line from the peak of a triangle down, you're creating an altitude. Now, what do you notice about H and BC in this case? They're the exact same, yes?
Yeah.
So, if it happens once, how often do you think it happens? All the time. Way to zen it up, Elma. All the time. So, if our altitude equals our unknown, right? The altitude, H, is the third side, then we get a right angle triangle. Does everyone see that? Because the H is 3 and the third side was 3. Is everyone cool?
Yep.
That's what you already know. That's nothing new. But watch what will and can happen. What is your guys' next set? Like your angle and distance measurements. Pardon me? 36 and 2? Make sure I'm doing this right. Okay, 36 and 2. So that is, no, there's the 3. There's the 2. That's cool? Okay, so let's draw it. Does anything change? We draw it with 30. There's 30. Okay, let's keep this being 6. Now, we don't know the third side, do we? It's 2. Everyone cool? All right, now, So let's draw in our H. There's my H, which of course is an altitude, correct? Now we already know what that altitude is, don't we? What is it? H has to equal what number? 3. Everyone agree? How long is BC? 2. BC is 2. It's the red line. What do you see? Is it as long as H?
No.
So can it make a triangle?
No.
Can it? So what does that tell us? If H is what? How does H relate to the third side? Bigger, smaller, the same? What is it? In this case.
It's bigger.
Right. H is greater than our third side. What did that tell us? Could you even make that triangle? No. If H is greater than the third side, you can't make a triangle. And I am going somewhere with this, guys. Trust me. Everybody cool with that one? All right. Well, because of what we just did. Sine of 30, right? That's what we just did. Sine of 30 equals H over 6. 6 sine 30 equals H. So H had to equal 3. H was greater than our unknown. Is everyone cool? Okay, what's your next one?
36, 8.
36 and 8?
Yeah.
8? So that one. All right, so let's draw it. 36. Everybody cool? Okay. So our altitude would be right here, yes?
Yep.
Which we know has to be 3, correct? Everyone good? So I'm going to use a red line to do our third line. How long is it? 8. Everyone agree? So this line would be this long, wouldn't it? Does everyone agree? Because it's got to be longer than 6, yes? Does that make a triangle? No, because I need the whole side. Does it make a triangle? Makes almost the flag in Nepal. Are we okay with how that's not a triangle right now? Right? Now, can I make it a triangle?
Yes.
Yes. How? If I swing it this way, will it make a triangle?
Yes.
It can go out here and make this. Is that cool?
Yes.
What happens if I swing it this way? Will it work? Can I ever make a triangle? Why? How long is this red line? 8. How long is this black line?
6.
So if I swing it this way, will it ever make a triangle?
No.
No, because it's longer than the 6. Is everybody cool with that?
How about the bottom one? How does it extend?
Well, because you don't know the length of the bottom one. So in this case, that's why it's ambiguous. You don't know what's going to happen. You have to think about it. So I could swing it out this way, and then I could make that triangle. How many triangles can I make? So far I've been able to make no triangles. I've been able to make one 90-degree triangle. What's the only triangle I can make here? Can I make a triangle? Can I make a triangle? Yes. Is it a 90-degree? No. So what would you say about this triangle? What's the only thing you can do? You can make one triangle, and it has to have an angle that's bigger than what?
3. No.
The angle. So far I've been able to make
Bigger than 90.
bigger than 90. I can make one triangle with bigger than 90 degrees. What do you call bigger than 90 degrees? What's the fancy? Obtuse. One obtuse triangle. And I'm lazy, I'm going to draw a triangle. Now think about it. If our h was shorter, or if our h was exact, we could make one triangle, 90 degree. If our h was bigger, no triangles. Right? What about this one? If our h is less than our third side, no, yeah, h is less than our third side, but what else? Our third side must be greater than our known side. And again, I am going somewhere with this.
Is the height always going to be 3?
No, that's just what we're using to prove it because it works out to a half.
Yeah.
Okay, it's a nice fraction we can work with. But it will always work. Whatever that is, you would check your h. You get your h. Is everybody okay? All right, now, do you guys have anywhere 36 and 4? Do you guys have that written anywhere?
No.
Really? So you don't have 36 and 4 written anywhere? That's a bummer. Do you have any blank space left?
No.
That's even more of a bummer. Okay, well, here's what I'm going to do. You guys are just going to think about this, because time's about up, and I'm going to cut you a break. You're not going to have any work tonight, because I want you ready for your quiz tomorrow. Let's pretend you have 4. Just look and think. 30, we're keeping that, yeah?
Yeah.
We're keeping 6. We know our h is 3, yeah?
Yeah.
Now, if the 4 is here, can I go this way? Will that make a hypotenuse that is longer than 3? Is that okay?
Yes.
Right? Now, can I go here?
Yes.
Does it make a hypotenuse
Yes.
longer than 3?
Yes.
So how many triangles can I make there?
2.
It might be this one, or it might be this one. Does everybody follow me?
Yeah.
If h is less than our unknown side, and our unknown side is less than our known side, then we can make 2 triangles. Okay? Now that's the complicated one. I don't know how that got erased from your notes. I'm a little peeved because you can see I have it right here. And all I did was push Control P. So I don't know what's happened. So do yourselves a favor, and before Wednesday, make sure you give this a look. If you only look at one thing on YouTube, look at this one because you don't have notes on it. And understand why this can be on both sides. Does everyone understand why? Because this is 3. So because this side is 4, it will fit here because it's not longer than 6. Yeah? And it can go there, which would extend or shorten the bottom leg. Everybody good? That's why it's ambiguous. That's why that one should have been first. And if you look on my notes,
What probably happened is
it was first. See? I had that one first.
you probably accidentally highlighted it.
I bet I highlighted that one and hit return or something to erase it, then hit Control P.
Yeah.
All right, now listen. Your quiz tomorrow is basically that. Okay? So if you want, go ahead and take a picture of the backboard. Because that is basically your quiz tomorrow. Special triangles and unit circle. Yeah? Okay? Photobomb! Way to go!